Hello everyone, I am Aniket Maheshwari from MSc Computer Science, Pondicherry University. Here I am presenting a genetic algorithm research paper on optimizing shipping cost, which is referenced from Indranil Deb Ranjan Kumar Gupta, Department of Management and Marketing, West Bengal State University, Barastar, Kolkata. The topic is the genetic algorithm approach to balanced allocation with serving unit and hub restriction. It is a type of zero one knapsack problem. These are the things that are present in my presentation, that is introduction, what is the problem, what is genetic algorithm, the balance allocation problem, heuristic optimization technique, that how we are solving it, genetic algorithm based heuristic optimization technique, and the code and its conclusion. Introduction. Welcome to the presentation on the balance allocation problem involving overall shipping cost minimization with restriction to the number of serving units as well as customer hub. In today's global economy, efficient and cost effective transportation of goods is crucial for business. The balance allocation problem is a complex optimization problem that involves finding most efficient way to allocate resources such as vehicles, warehouses, and personnel to meet customer demand while minimizing shipping cost. This problem has significant real-world application in industries such as logistics, manufacturing, and distribution. Throughout the presentation, we will explore the use of genetic algorithm and heuristic optimization technique to solve the balanced allocation problem by clear understanding of what a genetic algorithm is, how it can be used to solve optimization problem. Let's move forward. Now, let us discuss what is genetic algorithm. A genetic algorithm is a type of optimization algorithm that is modeled after the process of natural selection. It works by generating a population of potential solution and then selecting the best one to produce the next generation. This process continues until an optimal solution is found. In our problem, we are also going to do this. We will find different types of solution of our problem, that is of warehousing, shipping, minimal cost, and after finding all the solution we will find the best solution. Genetic algorithm has been used to solve a wide range of optimization problems, including scheduling, routing, and resource allocation. For example, they have been used to optimize the layout of factories, to schedule production runs, and to optimize the supply of chain logistics. Next, move forward. What is the balanced allocation problem that I am going to discuss in through the research paper? This is the balanced allocation problem is a complex optimization problem that involves minimizing overall shipping cost while taking into the account number of serving units and customer hubs. Like in this problem, there are so many serving hubs, customer hubs, and the number of warehouses. We have to minimize the shipping cost between the customer hub and the serving units. Thus, this problem is particularly challenges because it requires balancing multiple factors to achieve the optimal solution. Here, we will go that how can we solve this problem. To solve the balance allocation problem, several factors must be considered. First, the number of serving units must be determined to ensure that all customers are served effectively. This is the first content that we are discussing. Second, the location of customer hub must be taken into account to minimize shipping distance and associate cost. Finally, the overall shipping cost must be minimized to ensure the profitability. Here, we are here. This is the technique that we are going to use. This is heuristic optimization technique, which said it is a class of problem-solving method that use intuitive trial and error approach to find approximation solution to a complex problem. This technique are often used when traditional optimization algorithms fail or are too computationally expensive. Heuristic optimization technique can be used to solve wide range of problems, including the balanced allocation problem that is our problem that we are discussing here. As an example, we will take the problem that have been successfully solved using heuristic optimization technique include the training assessment problem, the knapsack problem, the problem that based on our and the job shop scheduling problem. In each of these cases, heuristic optimization technique were able to find good solution quickly and effectively. Here is a genetic algorithm based heuristic optimization technique. A genetic algorithm based heuristic optimization technique is a powerful tool for solving complex problems such as the balance allocation problem involving overall shipping cost, minimization with the restriction to the number of serving unit as well as customer hubs. This technique works by mimicking the process of natural selection, where the fitness individuals are selected for reproduction and their characteristics are passed down to the next generation by applying this process to a population of potential solution. This algorithm able to converge on an optimal solution in a relatively short amount of. Here is the implementation of my code as I take to solve the minimization problem that I am taking to get the desired output and taking input also. Like let's start the code. I use Jupyter Notebook as a code editor and use Python language for solving this. Like I started from import numpy is np. It is a library for solving math problem. Here are the some variable that I defined for problem parameter that are m, n, lp have some starting values. M is stand for number of customer hubs, n stand for number of warehouses, L stand for maximum number of warehouses per customer hub, and P maximum number of customers hub per warehouses. L and P are there vice versa, and we are creating a demand matrix. What is the demand from the customer that have a q is equal to np dot array. We are creating it into array and giving the starting value that is 10, 15, and 12. And we are also creating a cost matrix that is w have initial value 5, 8, 6, 9, 10, 7, 7, 6, 8. Here is the genetic algorithm parameter that we are genetic algorithm using genetic algorithm we are solving this problem, and we are giving some of their parameters, which is pop size, which is 10 yani population size, max gen maximum number of generation 100, probability of crossover zero point 0.8, probability of mutation zero point 0.1. This is the initial parameter that we have taken and some initial values. Now go through the code. We are defining an initialized population. It is a function, user created function that I am creating. Here the population created for in range pop size. We I am taking a variable in which I am saying random radiant 0 np dot max plus 1 comma size is equal to m comma n. Here we are taking the maximum from this. In the x we have np dot zeros m comma n. Data type is equal to int, and we are changing its data type to int. For I in range m, selected warehouses. Now we are calculating for selected warehouses. What are the warehouses? Is equal to np dot random dot choice. We are choosing from n comma size of radiant 1 comma 1 plus l plus 1. We are going for next iteration, and if it is not there, then the value is false. Now we are giving value to x, which is I comma selected warehouses is equal to 1. Then we are population dot append v comma x if return the population. Now the next function is for calculate fitness chromosome, where v is the chromosome, total cost values np dot sum. We are multiplying the above that we have created v into x and returning the total cost, which is the minimized cost. Let's go forward. Here we are creating another function which is selection of population. Here we are doing sorted population. We are just taking the shortest population for minimizing the cost. In this sorted population comma, we are taking key is equal to lambda x, that is calculate the fitness, and reverse is equal to true. And here we are calculating the probabilities. What are the probabilities? This customer and the shipping units, and returning the sorted population for I in select. I is the number of customers or something. Now go forward. There is a definition of crossover where the parent comma parent 2, in which v1 x1 are parent 1, v2 x2 are parent 2, and crossover point is radiant 1 comma n. N is the parameter that will be passed, and the value that is given by the user. Here we are creating two child like v child one, x child one, v child two, x child two, which have their value crossover point, and return the v child one, x child one, and v child two and x child two. Now this is the last definition, mutation chromosome, which almost similar to above, and we are creating some matrix and comparing it and returning the value of v comma x. Next, move forward. Here the implementation for genetic algorithm, where population is equal to initialize population for generation and range. This is max gen. Then we are creating an variable offspring which have a selection of from the population, which is muted offspring, and we are initializing is as zero. Now moving forward for chromosome and offspring, if np dot random random going forward, here it is returning the population is equal to population dot pop size, best solution for max population keyword, return best solution. Here we are giving the command to run the genetic algorithm, which is best solution that we are taking from this. Best solution is equal to genetic algorithm. Extracting the best solution, this is best B, best X that we have calculated in the above, and printing the solution, best solution, quantity matrix, and allocation matrix. This is the best solution, which is quantity matrix V11111, and the allocation matrix is 110, 0, 110, 110. This is the sample code that I created and the sample input that give Mia output. And here we go for the conclusion, which is in conclusion, we have learned about the valence allocation problem involving overall shipping cost minimization with restriction to the number of serving unit as well as customer hub. This is an important problem to solve because it can help companies save time and money by optimizing their shipping routes. We have also discussed genetic algorithm and heuristic optimization technique, which are powerful tools for solving complex problems like this one. Genetic algorithm based heuristic technique, we can find the so many problems, and in this problem that we solved, it is minimum shipping cost from warehouses to customer hubs. That's all. Thank you very much.